Okay, today we're going to be starting to look at probability. And before we start really diving in deep to probability, we're going to begin by defining a few terms that are going to be really useful and key for us moving forward. So, let's move that out of the way. So if we do some experiments, the result of an experiment is known as the outcome, or the elementary event. A combination of these is just known as an event. So say we've got a dice. We've got our dice here, and if we roll the dice, there are 6 outcomes: 1, 2, 3, 4, 5, and 6. So there's 6 possible outcomes. Say we wanted to know if we wanted to think of just odd numbers. So for obtaining an odd number, there would be 3 favourable outcomes, namely 1, 3, and 5. So when we're talking about the outcome that we most want, we define it as the favourable outcome. Now, with rolling a dice, that is if we've got a fair dice that's unbiased, that is a random event. So when we're selecting objects at random, we need to ensure that each has the same chance of being selected. So this method is called fair or unbiased. So you can get dice that are made in such a way that they'll be biased to one particular outcome. And the selection of any particular object is said to be equally likely or equiprobable. So equiprobable when the outcome of an event has the same probability. So if we were to select when one object is selected at random and there are n objects, the probability of selecting any particular object is said to be 1 over n. The probability that an event occurs is equal to the proportion of equally likely outcomes that are favourable to the event. So, if the probability of some event is equal to the number of favourably equally likely outcomes divided by the total number of equally likely outcomes. So if we were to consider, let's look at what that means. So consider randomly selecting one student from a group of 19. Now in that group we've got 11 boys and 8 girls. So in our little equation up here, the number of favourably equally likely outcomes, so that would be, so we've got a total number of 19, so that's our n is 19. But say we were talking about the number of boys, that would be 11. There's because there's equally likely the boy's a boy and the girl's a girl. But if we were talking about just selecting any one student, regardless of whether they're boy or girl, that would be any one over, so the probability of selecting any particular boy or girl is equal to 1 over 19. But the probability of selecting a boy is going to be 11 over 19, and the probability of selecting a girl is going to be 8 over 19. Because in this instance, 11 of the 19 equally likely outcomes are favourable to the event of selecting a boy, and in this situation 8 of the 19 equally likely outcomes are favourable to selecting a girl. Now, exhaustive events. So say we have a set of events and they contain all the possible outcomes. The most simplest one to think about would be flicking a coin and landing on a heads or a tails. So in this situation, if we've got the set of events that contain all possible outcomes of an experiment, it is said to be exhaustive. So in a special case, so say we've got event A and its complement, and the complement not A, so the opposite, the sum of their probabilities is 1. So the probability of A plus the probability of not A equals 1. If you remember in set notation, we would have, so we have probability of A, and for set notation the probability of not A is written A dashed equals 1. So in the example of tossing a coin, so the probability of heads is 1 over 2, the probability of tails is also 1 over 2, and these are exhaustive, so the probability of a half plus a half equals 1. If we were rolling a die, the probability of less than 2 is going to be 1 over 6, because the only one that's less than 2 is 1. that looks like an 8, 1 over 6, sorry. So, and then the probability of 2 or more is going to be 5 over 6, because there's 5 different outcomes. So and 1 over 6 plus 5 over 6 equals 1. And then if you were to say play a game of chess, you're either going to win or you'll lose. There's no other possibility. So there's a probability of winning plus the probability of not winning is going to add up to 1, and that probability will depend on other factors. So if we repeat an experiment, that's called a trial. So every time you repeat an experiment, that's a trial of that experiment. And the proportion of trials in which an event occurs is called the relative frequency. So the relative frequency is the proportion in which an event occurs. And we can use this to estimate the probability of that event occurring. So if we know the probability of an event occurring, we can estimate the probability of the number of times it is likely to occur in a series of trials. And this is a statement of our expectation. So in n trials, event A is expected to occur n times in the probability of event A happening times. And this here is our statement of our expectation. So let's look at an example and it'll become clear what that actually means when we look at this in a proper example. So let's say the probability of rain on any particular day in a mountain village is 0.2. On how many days is rain not expected in a year? So first thing to note is the probability of rain is an exhaustive event. It's either raining or it's not. So the probability of no rain is going to be equal to 1 minus the probability of rain. So 1 minus 0.2 is going to be 0.8. Now we know in a year is 360 days, so it's expected to occur 365 days multiplied by 0.8, which is 292 days. That is expected to be dry and not raining. So hope that helps.